it was Maisie again. So anyway, yeah, it's Pi Day. So we're going to be putting together a circuit that will calculate pi using the Arduino. It'll be using the spigot method to calculate pi. So we're going to output like, I think 1,000 digits will probably be sufficient. And we'll try to incorporate like a counter, maybe an LCD output to keep track of things. Haven't quite put it all together yet, so we do have another prototyping board here. Maisie's going to inspect it for us, but here we have the Key Studio MEGA2560. This is going to be a little bit faster to calculate the digits of pi, and also has more memory. So I think we might even be able to push the buffer of 1,000 digits out to maybe 5,000 digits. We'll see. But the idea basically is just to calculate pi for as long as I get interested in watching it. It'll output about maybe 1,000 digits to the serial port. We'll start putting some of the stuff together here. Maisie's having an amazing time. She is, of course, the star of the lab cats here down in Chuck's laboratory. On this, if it survives Maisie's markings here, that is. And we'll leave the 595 bit rotating circuitry on the other one. So we'll be back in a few minutes and see how things worked out. Well, sure enough, the few minutes later turned out to be the next afternoon. Most of that is because of the algorithm to calculate pi I wasn't quite clear on. I was going to do batches of 1,000 digits or even a couple thousand digits and then output that to the serial port and then just keep capturing them thousands of digits at a time. But the pi algorithm doesn't work quite like that. Started outputting the first 1,000 digits of pi. I was very excited and I was waiting for the next 1,000 digits, and then it repeated at 3.14159 again. So I was kind of a little confused, but eventually realized that we need to just output the digits of pi one at a time out to the serial port. So the code has been modified slightly to do that, so that it does output the digits of pi. I'm going to do a little bit of tweaks on it because it just outputs the digits. I want to put some formatting on the output, maybe even address the serial port. And most of the wiring on the prototype board here is done. We have the 595 shift register in there operating the display, but currently we have all 4 digits operating on the same output, so we need to break it out so that the 4 digits are operating separately. Now that we've at least confirmed that the digits working correctly and the software is more or less working correctly, we'll get to that now. Okay, we've had to make a few tweaks to the display, and it still doesn't have a really great output on it. I'm not sure if it's just because I'm not giving the digits enough time to settle in. But anyways, we're going to go ahead and try it here. We do have the pi calculation code here, and we're going to connect up the serial port. Alright, let's connect up that serial port. Here we go. Hope you're ready for some pi, even though it's the day after pi. Alright, there we go. We are calculating pi like crazy. It has 1,000 digits to get to. We'll let it do its thing. Of course, there's a very important part of the pi we really want to look for near the end. So we're going to come back and check for that once it's done those 1,000 digits. Well, you can see we're at 995 and 1,000. Okay, there we go. We have wrapped up a few runs of this, and on the output here on the screen, it's probably not very large, but we did several passes of this, and they took 186,468 millis, so 186 seconds, 186,468. Here's 3 in a row. But the first one, the very first one that we ran after compiling and uploading, was 186,467. One few milli than the other 3 or 4 attempts we did here, which I thought was interesting. Not a lot, but you know, it would certainly matter in racing. I think margins in Formula One, at least certainly on the pole position grid, have been challenged by smaller margins than that. So let's just grab a row here. We have our first 1,000 digits of pi. We just highlighted it, copied it to the clipboard, and first thing we want to do is just have a look here, and I've made just a little formula here that's going to pull out the 760th character and then the next 12, because we're looking for Richard Feynman's series of nines. And there they are. We have Richard Feynman's 6 nines at the 762nd, and carrying on for the next 6 spots. 6 nines in a row. Couldn't find any attribution to actually claim that Richard Feynman called them the nines, or claimed that these nines were relevant in any way, but that's what they're known as, and there they are. We have our 6 nines in the correct spot. Let's now take the text here, and just make sure we're having clipboard still. Head over here. Now I've got the first 1,000 digits of pi from I think a Cornell website, and we're going to drop our calculated 1,000 digits of pi here. You can see the end correct. It's a good start. Hit the compare button here. Oh, there they are. The two texts are identical. So there we are. We have accurately counted pi to 1,000 digits, and I'll upload the code to a Google Drive and put the link in the description. To be fair, actually, Grok AI helped with a good part of this. This section here, the loop to actually calculate the digits of pi. I'd never worked with the spigot routine before, so thanks a lot, Grok AI, for helping me a lot with the calculation routine here. And thanks a lot for joining as we use the Arduino to calculate pi to 1,000 digits, 186,468. Hey, how many seconds is that? 186 seconds. How many minutes is that here? 3.10. It's almost pi minutes. That's wild. Well, on that note, thanks a lot for joining us, and have an awesome day. Come back to Chuck's Laboratory anytime.